All right, ladies and gentlemen, welcome back. In this video, I want to take the time to identify some key theorems, postulates, and properties, and really focus in on when do we actually use these theorems, properties, and postulates. And so the first one that I want to talk about is the reflexive property, because overall it is actually my number one look for. Now, I will admit that it is used a little bit more frequently when we are discussing triangle congruency, which actually is chapter 5 for us when we are trying to prove that two triangles are congruent. The reason why it's my number one look for is because when you see a side that is shared, for example, if I'm talking about our reflexive property of a segment, this segment that I just created, we'll call it AB, is a part of both of these triangles. And so it's always the easiest thing that we can possibly do is to claim right away that AB is congruent to itself by the reflexive property due to the fact that it is shared in both of these, for example, triangles. But it also works when we're talking about angles. So let's say, for instance, we're talking about, again, I'm going to use a triangle as an example. We have a triangle here, but then I outline this triangle and create this one here. Well, this angle A, this angle right in here is shared in both the red and the blue triangles. Excuse me. So that means angle A would be congruent to angle A. So we want to use that to our advantage because it's very simple to use these congruency statements when they share a side or an angle. The next one I want to talk about is the vertical angles congruency theorem. This is my number 2 overall look for in all proofs. Why? Because we all can simply identify that vertical angles are congruent. We know that we have our vertical angles. We can say, hey, if this is A, B, C, and this is X, B, Y, from this angle right in here and this angle right in here, I can easily say that angle ABC is congruent to angle YBX by the vertical angles congruency theorem. So we're going to use this to our advantage as much as possible because it's a very easy angle to show congruency by. Now, I'm not saying all the time it has to be used, but it is very helpful to use a lot because of the ease of introducing these congruent angles. The next one I want to talk about is both the congruent supplements and the congruent complements theorem. Remember, the congruent complements theorem and supplements theorem basically says, hey, if angle 1 and angle 2 equal 180 are supplements, right? And angle 1 and angle 3 equals 180, then there is no physical way that angle 2 could not be congruent to angle 3. And so we make that conclusion. And so we're going to use these in a variety of different situations. A lot of times what the task will be to show that two angles are supplementary or two angles are complementary. And then we use this pairs of statements to then make a conclusion about these two angles using either the supplements or the complements, and of course that will just change the 180 or the 90. The next I want to talk about is the right angles congruency theorem. The right angles congruency theorem obviously states that all right angles are congruent. But we got to be careful here, okay? When I say that the measure of angle A equals 90 degrees, let's say for instance, I have this right here and there's angle A. The fact that it equals 90 is the definition of right angles. But what I could say is that, hey, if the measure of angle A is 90, all right, then I can sit there and say that angle A is right. And then if somewhere else in the proof I had that angle B is right, I can then say that angle A is congruent to angle B by our right angles congruency theorem. And so that's how we would utilize our right angles congruency theorem in practice. Once we actually state that two angles are right, then once they are classified as right, I can classify them as congruent using right angles congruency theorem. All right, next on up we have the linear pair postulate. Remember, the linear pair postulate tells us that if two angles do in fact form a linear pair, so something of the nature like this, these two angles, we'll call this angle A and angle B, these two angles form a linear pair. If they do form a linear pair, what's great about using this postulate is you can introduce it to say two different things. You can introduce it when you are trying to show that two angles are supplementary. So let's just simply say that you have angle A and angle B. You can introduce it to say that, hey, angle A and angle B are supplements or supplementary. And you can say that by the linear pair postulate. But you could also say that, hey, the measure of angle A plus the measure of angle B equals 180 degrees by the linear pair postulate. That's what's great about this postulate, because it is versatile and it allows you to use it in two different ways. But it just depends on the situation. If you have another set of supplementary angles, you may want to go this route, because that way you can go ahead and possibly use the congruent supplements theorem or something of the nature that comes on into play. When you're going to be focusing more on substitution of values, you might want to go this second option, because you're going to actually be putting numbers and equal signs into the mix. And the last postulate I want to talk about is the segment addition postulate. There's a couple different ways you can kind of use this, but in my personal opinion, the most common way to use segment addition postulate is when you are trying to introduce new features. So let's just say, for instance, I have a segment that looks something like this. They'll draw for me. And let's say that's A, that's point B, that's point C, and this is point D, okay? So if you're trying to make some kind of connection, let's say our goal is to prove that AC is congruent to BD. And let's say that they gave us already that AB and CD were congruent to each other. Well, somehow, some way, I have to introduce AC and BD into the mix. And so we can introduce these segments and make them a part of our proof by using the segment addition postulate. So I can maybe use it to say that, hey, I know that AB plus BC actually equals AC. And I also know that BC plus CD equals BD, all by the segment addition postulate. Well, now, let's just say, for instance, we kind of carry out this proof. We know that BC is congruent to itself by the reflexive property. This situation gave us that AB is congruent to CD, and so now I can use reflexive property and substitution, and then eventually transitive property to show that AC and BD are in fact congruent to each other. But again, the point of this is to identify when would I introduce the segment addition postulate, and that is a way that I can introduce segments that are not already talked about in our proof, or possibly they are already not given to us in our given statement. So hopefully this video helped on out. I highly recommend watch this video a couple of times to identify what are some of the key times we use these theorems, these postulates, or possibly even the properties as well too.